Okay, this is Algebra 2, Lesson 21. Today we're going to talk about two things. We're going to talk about scientific notation and two statements of equality. What is scientific notation? Basically, scientific notation is a product of a number that's greater than or equal to 1 and less than 10, and some base power of 10 where 10 is raised to a whole number. Okay, so basically that's what it is. So let's look at these two. If we take this, and we like using 10 because when we multiply or divide by 10, we simply are just moving the decimal over to the right or to the left. That's all. So it makes it much easier, especially when we're talking about huge numbers. So let's look at these up here. So we take this to multiply this. Basically, 10 squared is 10 times 10, or 100. So if I want to go and prove it, isn't that 10 squared? How many zeros are in here in this power? 2. How many zeros in 100? 2. What is 10 to the fourth? It's 10 times 10 times 10 times 10. Isn't that simply 100 times 100, or 10,000? Can you see that? There's a glare there. It's simply 10,000. How many zeros are in 10,000? There's 4. There's 10 to the fourth is got 4 zeros. So basically, you're counting zeros for exponents as well. So that's the relation there. So anyhow, so when we multiply by 100, we're making a number bigger. So when we're making a number bigger, we have to move the decimal to the right. So because you have 10 squared, that's 2. So you're going to remove your decimal place 1, 2, and now it simply becomes 41,203.6. And here times 4, remove it 4 times. 1, 2, 3. I don't have any more numbers. Well, then you put a space and you fill in with 0, like you did here. So now you have 4,120,360. Yes? When we have a negative exponent, let's look at the same thing, but with a negative exponent. So if I have 412.036 times 10 to the negative 2, what do we know about negative exponents? Well, that's 10 to the negative 10 is the same, negative 2 is the same thing as 1 over 10 squared. Doesn't that mean 1 divided by 100? So basically, you're dividing this by 100 when you have a negative exponent. Okay, so that's why you move the decimal place to the left when you multiply. So to get this answer, we're going to move it to the left side. So it's going to be 4.12036. Okay, let's say it's the other one. 412.036 times 10 to the negative 4. I'm going to simply move it 1, 2, 3, 4. I have to add a 0, so it's 0.041336. Okay, so basically you're going to either move the decimal to the right or to the left. So we can put the decimal anywhere as long as we please, as long as we follow the numeral with times 10 to either a plus or minus b. And we can use notations to tell where the decimal point really should be. So let's look at this number here. Let's look at 304.162. Okay, I can change it to say, if I move this to the decimal 1, 2, 3, I can say 0.304162 times 10 to the third power. Or I can change that number to say 304.162 times 10 to the negative 3. All three of these numbers are equal. They're just written differently. That means the same thing. So we can say we've written it in scientific notation. But we said to be in scientific notation, it's the product. What does product mean? It's the answer to multiplication. So the product of two things. Some number that's greater than or equal to 1 but less than and less than 10, and some power of 10 where that power is a whole number. So basically that is what scientific notation is. It's a product of some number greater than or equal to 1 and less than 10 times 10 to some power. The power has to be a whole number or an integer. Yes? Okay, so let's look at some examples on how we can use this. This really comes into play. Mostly you'll use, like when we want to use this, we'll use this in talking about a lot of money. We're talking about physics and science. It's usually because we're talking about bigger numbers. So let's look at this problem. This is simplified. Sorry about all the noise of this board. Okay, how do we simplify? First thing we do is we want to put them all in scientific notation. So here, as I'm moving it to the right, this becomes what? 1, 2, 3, 4. So it becomes 3.0 times 10 to the negative 10 power. Okay? Because I already had a negative 6 because I moved it to the right. You do the opposite, which is a negative. That's 4 times. So negative 4 and a negative 6 gives me a negative 10. Then this one, my decimal's here. So I'm going to go 1, 2, 3, 4.0 times 10 to the third power. As I moved it to the left, the opposite of negative 3 is positive 3. Okay, so then I come over here, and I'm moving it to the right. 1, 2, 3, so that's 6.0 times 10. So because I moved it to the right, 3 places, that's a negative 3 and a positive 15. So I get times 10 to the 12. You guys see that? It's really important that you understand that. Okay. And then I'm going to change this one. 1, 2, 3, 2.0 times 10 to the, I moved it to the left, negative 3, opposite of 3 is positive 4, so positive 3 and a positive 4 is 10 to the 7. Okay, so now, because of my associate property multiplication and my commutative property, I can simply do this. I'm going to drop these zeros. I'm going to leave them whole. 3 times 4, 10 to the negative 10 times 10 cubed, 6 times 2, 10 to the 12 times 10 to the 7. Right? Because of my associate property and my commutative property multiplication. That's why these properties are important. When you're in elementary, you're like, it doesn't make any sense. Why do I need it? Well, you need it for now, so you can do this. So can't I simply do 3 times 4 is 12 over 12, which is simply 1. Then I've got exponents. We've learned product rules. How do you multiply x? You have to have the same base, and you add the exponents. Negative 10, that's a negative 10, remember, and a positive 3. So it simply becomes 10 to the negative 7. And here you have a positive 12 and a positive 7, so you have 10 to the negative 19, or simply 10 to the negative 7 over 10 to the negative 19. And you're like, okay, now what do I do? Can you simplify any further? Yes. You have 1, so you have 1 times that right now, because isn't that equal to 1? Well, simply you use your quotient. You use your quotient rule for exponents. And what is that? It's the numerator. So you have to have the same base. Let me see this over here. You take the power of the exponent of the numerator minus the power of the denominator. So you have a negative 17 and negative 19. Simply, you're just using your exponent, your integer rules. To like sign to add them. So this simply becomes 10 to the negative 26 power. Or simply 10 to the negative 26. There you go. It's in scientific notation. Okay? That's all it is. You're using exponent rules. You're using properties, commutative properties. You're using associative properties. And then you're using multiplication and division and fraction rules. Okay? So let's move on to equations. we talked about story problems, and we use letters like N for number of apples and D for, number, or N of D, or D for dimes. So let's just go straight into the example 21.2. It says the ratio of two numbers is 3 to 4, and their sum is 84. Okay, so it says what are the numbers? Well, we decided to use N for numerator and D for denominator. Okay, so we said N to D is equal to 3 to 4. Yes? And we said their sum is equal to 4. Right? They were into denominator plus 84. So now we can do cross multiplication. So we have 4n equals 3d. So don't we have two equations? And can't we change this one to say d equals negative n plus 84, or 84 minus n? All I did simply is I solved for d. So now we have two systems of equations. So can't I do substitution and substitute this in for d? So I can say 4n equals 3 times negative n plus 84. And I simply solve for n. I want to find the numerator. Negative 3n plus, okay, I'm going to add 3n to both sides. I get 7n equals 252. I divide by 7, n is equal to 48. So my numerator is 48. Can I find my denominator? Sure. I can simply say, put it back in either one of the equations, right? So we have two systems of linear equations. So I'm going to put it in this one because it's easier. So 48 plus d equals 84. I'm going to simply subtract 48 from both sides. So d is 36. So those are my two numbers. Okay. I'm sorry. I had this wrong. N was 36. I had them flipped. Okay. All right, let's look at example 21.3. So basically, we're just putting in what we know, making two systems of linear equation, and then substituting, or either using the substitution method or the elimination. Let's do this one. This one's we want to use elimination method, but you can use either method. It doesn't work. It doesn't matter. So the sum of two numbers is 128. So large plus small equals 28. Large number and small number. And the difference is 44. L minus S equals 48. What are their numbers? Well, I've got two systems, and I can simply, there's opposite, I can use elimination. So 2L equals, divide by 2, L oops, that was 128. That's 1. And this is 44. Sorry. So they're 172, which is L is 86. So can I find S? Sure. 86 plus S equals 128. Minus 86 minus 86, S equals 42. Those are your numbers. Does it matter where I put this 86? I can put it in this equation or that equation. It doesn't matter. Because remember, because they're a solution for both equations, it will fit either one. All right, do practice A and B. And your code for this lesson is put the number 99 for JJ Watt on your homework lesson number 19. All right, the number 99 on homework lesson 19. Goodbye.